Assalamualaikum. Today we are from AS1241D who would like to present Calculus 1 MAT-183 that have been teaching by Madam Zanaria. And this is our group members. The content of this video is application of differentiation and maximum and minimum problems.
In apply of differentiation, we have 5 subtopics, which is related rates, analysis of function 1, analysis of function 2, apply maximum and minimum problems, and the last one is Roller's theorem and mean value.
Introduction. So what is differentiation? Differentiation is a process of finding the derivative or rate of change of a function. In contrast to the abstract nature of theory behind it, the practical technique of differentiation can be carried out by purely algebraic manipulation using 3 basic derivatives, 4 rules of operation, and a knowledge of how to manipulate function. And this is an example of differentiation. Fs equal to Xn, f prime x minus 2 equal to nxn minus 1, y equal to xn dy over dx equal to nxn minus 1, and y equal to sin x dy over dx equal cos x, and the last one is y equal cos x and dy over dx equal minus sin x.
Maximum and minimum problem. Apply maximum and minimum problem involve finding the highest and lowest value of a quantity in real-world scenarios. This problem typically require the application of optimization technique, specifically the use of differentiation to determine the optimal solution. This can involve maximizing profit, minimizing costs, optimizing resource allocation, maximizing efficiency, or minimizing risk among their objectives. Problem statement. What to solve? The volume of a container is given by V equal to in bracket R2 plus 1 time in bracket R2 minus plus 20 m3, where R is the radius of the container. A. Find the value of R so that the volume of the container is a maximum. B. The maximum volume.
To solve applied maximum and minimum problem is to find the derivative, and then let the derivative equal to 0. Find the values of the variables. The last one is to do the second derivative test. If second derivative test is above 0, it's a minimum value, and if the second derivative test is below 0, it's gonna be a maximum.
The volume of a container is given by V equals bracket R square plus 1 bracket R minus 2 bracket plus 20 m cubes, where R is the radius of the container. Fine. The question A is the value of R, so that's the volume of the container is a maximum. So, to find the answer, we need to find first derivative, which expand the volume of the container first. So, that will be V equals R square multiplied by R square multiplied by negative 2, and 1 multiplied by R, 1 multiplied by negative 2. So that we get the answer is 3R cubes minus 4R plus 1. Next is to find the maximum, we need to put dV over dr equals to 0. Replace the dV over dr with the answer that we get earlier and equals to 0 to find the number of R. So, the equation now is equal to 0. Next, if we see the equation like this, we need to factorize using the calculator. So, first thing first, we need to go into mode and EQN and mode. Then, pick the degree number of 2. Then, put the equation to factorization the equation. After that, 3r minus 1 bracket bracket r minus 1 bracket equals to 0. Then the number of r equal to 1 over 3 and 1. So we need to use the second derivative to get the answer. Then we know that 1 over 3 is the maximum point. So, problem solution. The next question is the maximum volume. Solution: Vmax equals to the answer that we got earlier, but replace the r with the maximum volume to get the answer. So that will be Vmax equals to 1 over 3 cube minus 2 multiplied by 1 over 3 square plus 1 over 3 and 18. So after we do the calculate, the answer that we get is 18 over 4 over 27 m cubes. So that is the volume answer.
So, for the conclusion, after studying this topic, we must know and able to understand the idea of differentiation and find a suitable formula or method that fits the question given. The fields of the use of calculus are very wide. It enters into many fields and are not limited to specific people